In this session, we're going to see how to use the quadratic formula to solve quadratic equations. And the quadratic formula actually comes from completing the square in particular, or I should say in general, because this is generalized, solving ax squared plus bx plus c equals 0. And I tried to make it fast, but it seems too fast. So we'll just do this step by step. But you can relax and just kind of watch. This is in just about every textbook out there. Remember that when we're completing the square, we want that first coefficient to be 1, and we also want the constant to be on the right-hand side because we're only completing the square for the variable terms. So if I divide everything by a and then subtract the constant, I get x squared plus b over ax is equal to negative c over a. And notice I'm leaving that gap after b over ax because we're going to add the right thing to both sides to complete the square. To figure out what to add, we multiply the linear coefficient, b over a, by a half. That gives us b over 2a. And squaring that gives us the value that we're actually going to end up adding. In this case, b squared over 4a squared. We're going to add that to both sides. Plus b squared over 4a squared. On the left-hand side, we have x plus, as you may recall, what goes inside the parentheses matches what we got when we cut b over a in half, right? And the sign matches that term. So we have x plus b over 2a, the quantity squared, is equal to, now the negative c over a plus b squared over 4a squared needs common denominators, right? In this case, we're going to get that by multiplying numerator and denominator by 4a squared. I'd like to write the positive term first, so I have b squared. I'm going to write minus 4ac all over because we got common denominators, right? 4a squared. At this point, we have squared equals thing in an equation, right? So we can square root both sides, not neglecting the plus or minus. The square root cancels out the squared on the left-hand side. We end up with x plus b over 2a. And on the right-hand side, we get plus or minus. We're going to square root the numerator and get nothing pleasant, b squared minus 4ac, but square rooting the denominator, 4a squared, gives us 2a. Finally, we're going to subtract b over 2a from both sides. Since we have common denominators, I can write that as negative b plus or minus the square root of b squared minus 4ac all over those common denominators of 2a. And this is our familiar quadratic formula, which is just a generalization of solving by completing the square. Now there's a part of the quadratic formula, the part that's inside the radical. It's called the discriminant. The discriminant is b squared minus 4ac, and there are three distinct possibilities. The discriminant could either be positive, 0, or negative. If the discriminant is negative, that means we have a negative inside the radical, and that's going to give us complex solutions. And because of the plus or minus, we're going to have two of them. If the discriminant is 0, then we're only going to have one solution, because if you add and subtract 0, you don't get anything different. And that solution is going to be real. If the discriminant is positive, this breaks down into more possibilities. First off, if the discriminant is positive, we're going to have real solutions because it's a positive radicand. But because of the plus or minus, we're going to have two of them. The further breaking down that I mentioned are, if it's a perfect square, then we can fully simplify the radical, and our solutions are actually going to be rational solutions. We'll have two of them because of the plus or minus. If it's not a perfect square, then we won't be able to do away with the radical entirely, and we're going to have irrational solutions, but again, two of them. If our discriminant's a perfect square and we end up with those rational solutions, that means we could have factored the whole thing to begin with. And the reason I get into this is if you have to solve a quadratic equation and it turns out the discriminant's a perfect square, then you can solve by factoring. It's a quick check to figure out whether you should even bother trying to factor or not. In any case, now let's get on to our examples. In our first example, we've got 2x squared minus 5x minus 3 is equal to 0. And I'm going to rewrite the quadratic formula for reference here. So I've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And it might be good to use some color coordination when we try to flesh out the formula. So I'm writing a in blue, b in red, and c in green. So when I flesh out the quadratic formula, I might think about that a is 2. In this case, b is negative 5. Yeah, the sign of the number goes along with that letter, okay? And we could finally say that c is negative 3. Substituting for a, b, and c, we're going to end up with x equals the negative of negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times negative 3 all over 2 times 2. Let's explore this discriminant that we have. It's going to evaluate to 25. That negative negative is going to be a plus because that's multiplication. 24, which is equal to 49. Since that's a perfect square, we know that this is something that we could have factored, but we're instructed not to. We're instructed to use the quadratic formula for practice. That's just for general knowledge, let's call it. Anyway, when we simplify the quadratic formula, we have x equals 5 plus or minus the square root of, we've already figured out that the discriminant is 49, so we might as well put square root of 49 all over 4. Continuing to simplify, we get x equals 5 plus or minus 7 over 4. And this should be split up into two expressions because we can continue with these. And I'll show you the distinction in a few minutes when we can't continue. X is equal to now 5 plus 7 over 4 or 5 minus 7 over 4. Taking each of these in turn, we have 5 plus 7 over 4, well, that's 12 over 4 is 3. 5 minus 7 over 4, negative 2 over 4, reduces to negative 1/2. So x equals 3 or negative 1/2 are the solutions to this quadratic equation. Next we have 3w times the quantity of w plus 2 is equal to 5. I'd like for you to get all the terms on the same side, set it equal to 0, identify a, b, and c, and try to solve this using the quadratic formula. So here I've written the quadratic formula with the a's and b's and c's, and for me to be able to use it, I need to know what a and b and c are. So first thing I'm going to do is distribute the 3w into w plus 2, and I'm going to subtract 5 so that I have everything equal to 0, and the result of that is going to be 3w squared plus 6w minus 5 is equal to 0. And using the color coordination that we had before, when I flesh out the quadratic formula, I'm going to write down negative 6 plus or minus the square root of 6 squared minus 4 times 3 times negative 5 all over 2 times 3. Now we're going to take a moment and consider this discriminant again. In this case, it's going to simplify and become 36 plus 60, which then becomes 96. 96 is not a perfect square, but it is positive. So my solutions are going to be real. I'm going to have 2 of them, but they will not be rational. In other words, there's no chance I could have factored the trinomial. And again, just call that knowledge a tool in your toolbox. In any case, when we continue with simplifying the expression, we have w is equal to negative 6 plus or minus the square root of 96 all over 6. And you may be tempted to try to reduce the 6's don't do it because you can't divide out a term. We can only divide out factors. So our correct plan of action is going to be to simplify inside the radical, and as it happens, 96 is equal to 16 times 6, 16 being a perfect square, so that's going to come out of the radical as a 4. So I have negative 6 plus or minus 4 times the square root of 6 all over 6. At this point I want to reduce a fraction, and the way we do that is we factor and then divide. So I'm going to factor out what I see as common, and in this case that's 2. So I get 2 times the quantity of negative 3 plus or minus 2 root 6 over 2 times 3, if you want to factor that denominator even. And dividing out the 2's gives me w is equal to negative 3 plus or minus 2 times the square root of 6 all over 3, which I would accept as a final solution. If you wanted to further break this apart, then you might separate the numerator, and you'd end up with negative 3 and then over 3, right? Plus or minus 2 root 6, but that's also over 3. So that would become w equals negative 1 plus or minus 2 root 6 over 3. That's as simplified as we can get it. And this is what I was alluding to in the previous example. There's no point in separating the plus or minus because I can't further simplify those answers if I do. So 1 fraction or 2, I would accept either of these as your final solution. Next we have 12x minus 5 equals 9x squared, solving using the quadratic formula. So do what you've seen so far, give this a shot. So what I've done is written down the quadratic formula for reference, and I subtracted 12x and added 5 to both sides. It doesn't matter if the equals 0 is on the right or on the left, and I prefer it on the right. So the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm really just repeating that for emphasis to help you try to memorize it. We noticed that a is 9, b is negative 12, and c is 5. And when I put those into the quadratic formula, I'm going to end up with x equals the negative of negative 12 plus or minus the square root of negative 12 squared minus 4 times 9 times 5 all over 2 times 9. So x is equal to 12 plus or minus, the discriminant is going to be 144 minus 180 all over 18. So that discriminant becoming negative means we have x equals 12 plus or minus the square root of negative 36. And as soon as we know that discriminant is negative, we know that our solutions are going to be complex. And complex solutions always come in pairs. X is equal to 12 plus or minus, now that's square root of negative 36, that's a 6i, all divided by 18. And whenever we have complex solutions, this is just a math thing, you got to deal with it. We're going to want that answer in a plus bi form. A plus or minus bi form is fine, but it's technically referred to as a plus bi form. In other words, if you see i's, split the fractions. X is equal to 12 over 18 plus or minus 6 over 18, and then stick that I out as a factor. So 6 over 18 times I. I see these fractions can be reduced. We're going to divide 6 everywhere. So x is equal to 2/3 plus or minus 1/3 I. And that's how we want to see a complex solution. In our next example, we've got 1/4 m squared minus m plus 1/2 is equal to 0. And I really threw this one in just to emphasize that you don't ever need to, unless you really want to, put fractions inside of the quadratic formula. Instead, what I'm going to do is multiply by the least common denominator throughout, so I can clear all the fractions. Then I'm going to proceed as before, so why don't you pause the video and do all that on your own. So I've written down the formula for reference, and after distributing the 4 to both sides, we're going to end up with m squared minus 4m plus 2 is equal to 0. And I see a is 1. That's, remember, always there when we don't have a coefficient. It's 1. And b is negative 4. And c is 2. So when I flesh out the formula, we get, in this case, m equals negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 2 all over 2 times 1. Now, if you haven't already done so, take a moment and examine the discriminant. That discriminant becomes 16 minus 8, which is 8. It's positive. We're going to have real solutions. There are 2 of them. And notice, since 8's not a perfect square, they're not going to be rational. So m is equal to 4 plus or minus, we already figured out the discriminant is 8. So the square root of 8 all over 2. And now we can simplify. M is equal to 4 plus or minus, remember 8 factors into 4 times 2. 4 being a perfect square means it's going to come out of the radical. We're leaving 2 in the radical, so 4 plus or minus 2 root 2 all over 2. Now I want to reduce this fraction, which means we're going to factor and then divide. So the numerator turns into 2 times the quantity of 2 plus or minus the square root of 2 all over 2. The 2's divide out. So we have m is equal to 2 plus or minus the square root of 2 as our solutions to this equation. Finally, we have what we call a literal equation. We're supposed to solve a equals 2 pi r squared plus 2 pi rh for r. Whenever we have a situation like this and they give us a variable to solve for, I'm highlighting that, and we pretend everything else is a number. So what I want to do is express this in the form ax squared plus bx plus c is equal to 0 so that I can flesh out this quadratic formula with r playing the role of x. So I'm going to subtract a from both sides, and that'll give me 2 pi r squared minus 2 pi hr minus a is equal to 0. And comparing with the equation right above it, we're going to see that our coefficients are variables. So we have that a is 2 pi, b is, don't forget that negative 2 pi h, and c is negative uppercase a. So fleshing out the formula, we get not x equals, but r equals the negative of negative 2 pi h plus or minus the square root of negative 2 pi h, that whole thing squared, minus 4 times a, which is 2 pi, times c, which is negative uppercase a. We extend that radical all over 2a, which is 2 pi. Now I took the time to actually write all that out so that it wouldn't be really cumbersome to look at. And, well, we'll do what we can. R equals 2 pi h plus or minus the square root of 4 pi squared h squared. Now the negative 4 times negative a is going to become positive. Throw in that 2 pi, we have 8 pi a all over 4 pi. Now, inside the radical, that discriminant, first, we're not going to talk about positive or negative or anything like that. What I am going to point out is that we have a factor of 4 in both terms. So we're going to factor that out, and it's going to end up looking like r equals 2 pi h plus or minus, in the radical we have 4 times the quantity of pi squared h squared plus 2 pi uppercase a all over 4 pi. That 4 is going to come out of the radical as a factor of 2. It's going to give me r equals 2 pi h plus or minus 2 times the radical that has pi squared h squared plus 2 pi a all over 4 pi. And now we can factor out the 2's and then divide out the 2's. I'll cut to the chase here. R equals pi h plus or minus the square root of pi squared h squared plus 2 pi a all over 2 pi. And there's nothing I can do to further simplify this answer. I don't like the answer, but I don't always have to like it. This is that equation solved for r. That equation, by the way, if I can scroll all the way back up here, happens to be the formula for the surface area of a cylinder. I know you care about that.